So, a lot of companies are doing Scrum. How many people here are doing Scrum or something like Scrum? Scrum-ish. Scrum-ish.
Cargo Scrum.
Cargo culture. So, this is more or less Scrum in a single slide. That's one thing I like about Scrum. It's really easy to explain, right? We have a backlog. We have product owners. We have a team of Scrum masters. We have, a sprint planning, sprint backlog, sprint review, sprint retrospectives. We go in iterations, and then we have daily scrums, or stand-ups. So more or less, this is Scrum in like 2 minutes, right? So I want you to look at this slide and tell me, like, where in here, which part of this actually makes sure that your code is well architected and designed and tested? Which part of the Scrum model here really nails that?
Development team?
Pardon me? Yeah, true. Doesn't say how.
Yeah.
There's no guidance, right?
Fair.
Maybe the definition of done.
Right.
You could have, we should have unit tests for our code, or we should do something else. But fundamentally, Scrum is totally agnostic about how you build. So you could apply this process to building a house or something. So, one of the dangers is, or one of the, I would say, dangers of Scrum is that companies can feel like they're getting the benefits of Agile by adopting Scrum. But if you only do Scrum and throw away, say, some of your traditional practices, like writing requirements documents and analysis and design, you could actually be in for a world of hurt. Because could just be building stuff faster. Right? But you could be building crap faster. In fact, the best way I know how to build, Scrum is probably the best framework possible for building technical debt. If that's your goal, Scrum is a really great way to do it, right? I mean, unchecked. So what I want to do is talk about, how do you, what practices would actually help you not get into that mode. And this is right from the Scrum guide. So Scrum is not a process for building products. It's just a framework for which you can employ various processes and techniques. So the intent is that you add to Scrum. I think a lot of people miss that. And you'll see with some of the kind of high-performing teams or teams that have been doing Agile for a while, they will end up taking on other practices. And a lot of them will come from extreme programming, which is the XP. And we were looking at, if you look at how many companies now are using extreme programming, it's like plummeted. It's like zero. Like none of them claim to be anymore. Even though a lot of teams might use some of these practices. So I actually believe that extreme programming together with Scrum is a really powerful combination. And we're going to focus in on like the ones down in the middle there, which are the technical ones. So test first development, usually called TDD, design improvement, usually called refactoring, pair programming, and the bottom one we're going to talk about today, which is simple design. And I'm of the belief that engineering practices matter, that it's hard to execute day over day, week over week, year over year without good coding techniques. And this is one of the ways that, my favorite metric for code is WTS per minute. I pair programmed with Eric, and I got quite a few WTS per minute when I pair programmed with Eric, but they're usually looking at my code. But really, it's meant to be, our code is a communication tool, and we want to be able to, anybody, I think it's Martin Fowler or Brady Booch, I can't remember who said it. Anybody can program a computer. Anybody can write a program that a computer can understand. Our real goal is to write programs that people understand, and that we can communicate. So WTF is kind of a feedback that it does not compute in my brain. Right? So we're going to dig into simple design. So I'm going to jump there were various formulations of it, and I've decided to just distill it down into something that I think is easy to remember and easy to think of when you're looking at your code, and it's an extreme distillation, and it looks like this. It's just, code should be tested, clear, dry, and succinct. Tested, clear, dry, succinct. And that's pretty nice, because if you look at your code, you can ask yourself, is it tested, clear, dry, and succinct? So there are much more verbose definitions of this, but we'll go through each one of these in a little bit of depth during this session. Has anybody heard of this? I know, is this ringing a bell now with anybody? It does with Andrew. Andrew's, Eric maybe a little bit, vaguely. So we'll talk about tested. So tested is usually about TDD, right? In an Agile context, you're doing TDD. So it's, what is it? It's we're going to write our specs before we write our code. And if you think about it, think about how we used to code. Maybe when there were how many people used to have requirements documents and design docs and that kind of stuff, right? Maybe most of us have, right? So in that world, it was actually I actually liked writing a lot of those documents because you could actually, it was pretty clear what the thing was supposed to do. You could reason about it. You could actually reason about the design before you put in a lot of code. But those documents aren't any part of Agile, really. I mean, they are, but they're much lighter weight. And so, when do we actually think about, how do we express what it is that we want to build? And teams aren't writing tests. Then very often they're just going from like story to code. Here's a story, start coding. Where do you actually think and reason about what your system should do? And tests are meant to be that. Tests are a way to say, what should my system do? And doesn't it sound reasonable that you should have a specification for what you're going to code before you code it? That just makes sense to me. If I'm going to go do a home renovation and I need a board, I probably will measure first. Well, that's 52 centimeters, right? So I'll express a test by having, here's my test, it has to be 52 inches. And I'll make my cut, and then I'll go execute my test. And if, my home skills are really sucky, so it's a good chance it doesn't work, right? And then I have, in my case, usually some significant refactoring. But doesn't it make sense that we would express what it is that we want as a test first? And that's really what TDD is all about, is we're trying to write our tests before we write our code, so we're very clear about what it is that we're trying to do, step by step by step.
Do you find many teams that actually do really code their tests TDD to its true?
I find a lot don't, and it is a tough skill, but I think Eric and I work together. He'd probably tell you, I really push hard in that direction, and I challenge the team to do it in my own work. It's just a skill that you have to learn, and it feels like we're just taught that we test after the fact, so we're not taught how to write our tests first. But that's really, really an important part of simple design, is to try to write your tests first. Here are the rules. Do not write any production code until you've written the code that will test it. This is really the heart of TDD. And I find this, the mechanics of doing this are actually really darn simple. It's not hard. You just using JUnit or NUnit or RSpec or whatever your language is. It's really easy to write a test. And just like saying, it's pretty easy. You say how long. Go measure how long is that piece of wood. How should this code work? And the cool part is that, we used to always, to me, what the hallmark of good design is that it's testable. In fact, that's my #1 criteria for good design. And if I'm always having to design code thinking, I'm writing code, is this testable? I'm not sure if this is testable. How would I test this? Instead, I get rid of all that and I force myself to write the test first. But I never have to worry about it being testable. It just is, because it can be no other way. But it is something that I think if I think it is hard for people to get it, and it's painful to learn. It can be painful to learn, but it's actually easy to do and easy to start. And you could start with coding katas, like simple examples as a team. You could find, say, greenfield parts of your code that you're working on to try it, and then just start to ratchet up the team skill over time. This is the heart of the TDD rhythm: red, green, refactor. And the red is that you write a failing test first. Okay? We're actually not going to do that today, but and this is something that's actually kind of, I had a thought the other day, and maybe somebody's thought of this before, but I'm a big believer in the scientific method, right? And the core of the scientific method is having a falsifiable hypothesis, right? So if I hold a hypothesis, in the scientific community, that has to be falsifiable, right? I have to be able to prove that, I have to be able to run an experiment that proves or disproves it. That's all a failing test is that you're writing a test and you're showing that your statement is falsifiable by making sure that test fails first. And then you write the code to make it go green. Now you've just kind of proved your assertion that we can actually get our system to meet this specification. And I never heard it expressed like that. That kind of makes sense to me. It's like the scientific method applied to code. I'm going to assert something. Once in a while, I will write what I think is a failing test, and I go around and it passes. And then it's like, oh, that's good to know, because if I'd gone and kept coding this, they all would have passed. And sometimes it's like, that test is being ignored, or I'm pulling in the wrong class, or something's wrong with my test setup. And I might have blissfully gone ahead and thought that all my tests were passing, but in fact, it was a false positive because my test wasn't falsifiable. So we want to start with the failing test. I believe that tested is the most important thing. If you can do it first, TDD, then I think that's how that's my experience will work better. But having some tests is infinitely better than having no tests. So especially when you're learning TDD, if you write something and you have to test after, I would say, that's fine. Like you just gotta, don't worry about it, right? Just keep going. There was a hand up, or?
Sorry, I was covered in.
Okay. So tested is more. So being tested is more important than test first. But we're gonna do a little exercise where you can get some practice at test after. So Andrew is gonna hand out with my help some code examples. I want you to find a partner. Okay.
Oh, good.
And
I can
you're going to see some code that looks like this. And there'll be a white sheet. And I just want you to, if you don't have a pen, let me know.
Oh no.
Usually a sign that someone's just thinking procedurally and just putting a bunch of code in a Java class because they kind of are related, but there's not really a strong OO sense to it. Anything else in this?
Low repetition.
Yeah, we're going to get to that later. We'll get to that later. That's the dry part of simple. Yeah.
So if I was tasked with testing this for real, I would sort of be stuck with the question of, am I trying to test to make sure that it continues to do what it's doing, or that it's doing the right thing?
Right. Yeah.
That's the one thing that stands out to me is it's not obvious what the function is supposed to do. It's fairly straightforward with what it actually does, but what it actually does.
No, it's not.
Yeah. So what is the function supposed to do? And we'll talk about that a little bit, like what would be better names that might express the ideas more clearly about what it's doing. Cool. Okay. Well, that's the tested part. So now we could assume that we've written some tests for this code. And then we're going to talk about clear.